Hi everyone, welcome to the second in the three-part series of FPE 1001, a primer to format preserving encryption. It's where we talk about the technology format preserving encryption and how you can use it with your data. Format preserving, or FPE of course stands for the format preserving encryption. Um, it's a really powerful tool. It allows you to do a lot of cool things. I think we explored in part one, when the best time to use FPE is and when the best time, maybe even more importantly, when not to use FPE. So just a quick couple notes here. This is what we're going to talk about today. We're actually going to encrypt and decrypt data with FPE. We'll also kind of do a little preview into key management. How do you create keys? We'll talk a little bit about what some of our customers do with different keys. Another interesting thing is, so we'll do that and then we'll actually encrypt some data. We got about 2,000 rows loaded up in a database, so a relatively small sample set, but just enough for you to see kind of the power of the technology. And then we'll talk about how you can operate over the data once it's been encrypted. It's really important to allow the database, whenever you're protecting the data, it's important to allow the database to still be able to do a good job at being a database, right? If you have to go decrypt everything just to do simple things in the database, your data users are going to be really, really unhappy. You're probably going to burn up a lot of money on your capacity in your data warehouse. So we're going to talk about how you can still get function and form out of the data, even though it's encrypted and the risk has been removed. We've got a couple of examples of that. And then in the next part, I just always like to highlight about what's coming next, the impact of what we've done here. We'll talk about how does this look in a broader data ecosystem with your upstream and downstream producers and consumers of data. What are the business drivers? What kind of business outcomes can you get to with FPE? All sorts of things like that. So that'll be coming in the next section. If you didn't watch section one, I highly encourage you to go back and watch section one. It's just a really good overview on kind of the general properties of FPE. So we're going to go ahead and dive into the demo here. Want to do this all in one take so you guys can see that it's all real and everything. There's no man behind the curtain. This is real technology, and I'm going to show you how easy it is right here, right now. Let me just get my share switched over here to my browser where I've loaded up a little bit of a demo script for format preserving encryption. Throughout the course of the demo, we have two tables. We have a customers table and a transactions table. The tables are related together through the email column. So I believe I'm looking at the customers table here. Let's just reload that. Yep, so we've got, all of the normal things that you would expect in a customers table: email, first name, last name, phone number, street address, all of that. And then we've got a transactions table. Maybe this is, how much a customer spent or whatever in some kind of CPG company or something like that. So today, for this demo, we're going to focus largely on those email columns. That's important because those are the related columns. That's the column that relates the two tables together. We could talk about, SSN. The technology applies to it really any one of these columns. But it was important to me to show you the email column because I want to show you how you can maintain the relationship across the two tables. So first thing is, we always say in our company, the encryption is only as good as your key management practice. It's very similar to your house. I think I said this in the last segment. If you lock your house and then you always put your key under the doormat, eventually somebody's going to see you put your key under the doormat and your house is going to get broken into. So really what the Alter product in specific does, and you should contemplate this with any kind of encryption or FPE solution, it really gives you an elegant way to manage the keys. So we can just go ahead and insert a key into our table here, into our keys table here. What we're doing is we're creating a key. We're labeling it email _ CS. Go ahead and we can see number of rows inserted, 1. That's good. You'll see we just called two functions here. I'm going to give you a little secret. If we just run these functions, we'll create keys left and right. This table is just a mapping for how you utilize the keys. But something about this function is this key that we're putting on the screen right here. I'll go ahead and I'll circle it using my handy dandy John Madden feature. this text right here, this is not actually a key. This is a wrapped key. So, even though I'm showing you this text in a public Zoom right now, you really can't do anything with this key. And what that means is it doesn't matter how this table is protected. We obviously have written best guidelines on that, or best practice guidelines on that. But the key is secured. This is really a derivative of the key. It's called a wrapped key. We use a standard envelope encryption pattern. And so would encourage you to think about your key management practice in your encryption technology. Alter happens to manage this all for you. It makes it really nice for demos, and it really makes it really nice for our customers as well. So what we're going to do, again, we'll just pull back up this customers table real quick. Come on, Chris, do a good job. Pull up the customers table. We're going to go ahead and we're just going to update that email column, and we're going to encrypt it. Alter comes with a set of standard alphabets that you can use with your format preserving encryption. The alphabet is the set of possible characters that are eligible to be encrypted. If something is not in that particular alphabet, it'll be passed through into the ciphertext. That's what gives you the format preserving characteristics of the format preserving encryption. So we're going to go ahead, we're going to encrypt it. We're going to encrypt the email column. We're stashing that into the back into the email field, and we're going to use that key that we just created. So let's go ahead. We will do that now for this column. It might take a couple of seconds to run here. Again, we're referencing that email key that we created up here, and we just stored into the mapping table that these functions that Alter gives you references. So, okay. So we went ahead and we updated that. Let's just go ahead and double check our work. We'll pull back up that customers table real quick, and look at that. All of this data is now encrypted. You can see we have what looks like an email address here. It's got the same number of characters before the @ sign. It's got the @ sign itself because that @ sign is excluded in the encryption alphabet. Same number of characters after the @ sign, the dot, and then the 3 characters after that. So any kind of data quality tool, or even a human that's doing some kind of spot checking or analysis over this data, they can very clearly see that this is an email address. So we're going to go ahead. We'll do the same thing over the transactions table. We're using that same key. So one of the properties of format preserving encryption is that if you get what's called a deterministic property. And deterministic more broadly in any kind of computer science, it means given a same set of inputs, you will get a same set of outputs. The computer itself is actually a deterministic Turing machine. You always give it the same input, you will always get the same output. So in this case, we gave it email and we gave it the same key. So the encryption algorithm had the same key material. So those emails also got encrypted. We'll go ahead and we'll just double check that real quick. Those emails got encrypted with the same key. Let me see what else is in here. If we wanted to walk through the decryption real quick, we can call decryption on the fly. We'll talk about this a little bit more in a second. If we want to make the decryption part of the query or whatever, we get our emails back. No problem. But what is really kind of interesting about this is a couple of things. Because we leverage the property of determinism with the encryption, that means, remember in the beginning we talked about how we were choosing to do the email column. The email column was the related field between the two tables, the customers table and the transactions table. We're going to go ahead and we'll run a query right now. You'll notice as part of this query, there is no encryption or decryption operation anywhere in the query. These are all the same tables. It's not like we're querying over some view. Actually, really quick, just to make super duper sure, I can show you real quick. Let's just do this real quick. To make super duper sure there's no funny business going on here. This is the table. It's a very plain table. We don't have a policy intercepting the output or anything. We're querying the same tables that we just encrypted. And here we're able to perform this join action over this data, the customers and the transactions table, because of the property of determinism. So we're able to see all of a given customer's transaction using this join because the same email that was encrypted in the customers table got encrypted in the transactions table. So if chris@alter.com was encrypted in the customers table, chris@alter.com is going to get encrypted in the transactions table, and both tables will have the same ciphertext, which means the database still gets to be able to do all of the things the database is really, really good at, scanning over those tables, scanning over those pages, or in the case of Snowflake, the micro partitions, and creating those relationships and projecting them into the result set. There's no need for encryption or decryption here. The last thing, again, because of the property of determinism, your data maintains a lot of its analytical value still. So you're still able to do aggregations, not only just joins and unions and things like that. You can do all of the aggregation. So here we're seeing how many. Sorry, I'm in the wrong role here. That is the next part of the demo. I'll just go down here real quick. Switch my rollback. We're able to see how many times a given email address appears in the transactions table, or in actually in this case, this is the relations between the customers and the transactions table. And lastly, if I really wanted to, just to show the flexibility of the solution, I'm going to do this real time. I actually have no clue what's going to happen here. We will go ahead, and if we wanted to do this and still turn it into plain text, I believe this is what we call a risk. We can go ahead and we can put that decryption operation right into the projection. CS underbar email, I think, is what we call our key. Let's just double check that real quick. Email CS, we were close. We're going to go ahead and put that decryption operation right into the projection. We'll rerun that query, and what I'm expecting to see is a result set that looks very similar to the last result set, but we should get our plain text emails back, and we did. Just like that, the first record in the last result set had 107, and so we were able to augment our query with one simple function call to go ahead, decrypt those emails. And if your use case is that you need the plain text, great. You can get the plain text back by just very simply augmenting your query. Or you can use something like a masking policy inside of Snowflake. Alter can help you automate those through other portions of our product. You can use views if you need to, have plain text back in some cases. And then, but I guess to finish this off, the last thing I'll say is, it was one simple function invocation to turn that ciphertext back into plain text. So I'm going to switch this back just for the simple purposes of, I don't want to mess myself up at my next time I do this. The last thing I'll say, we were talking a second ago about masking policies. You can, there's a couple things that you can do. Let me get to the right spot here on the screen. You can govern the access to the encryption and decryption function. I don't want to get too much into policy on this particular talk, because this three-part series is really about FPE as a technology. But of course, if anybody has the ability to decrypt the data, it's not really that great. So we need to talk about it a little bit. You can govern through Snowflake grants access to the encryption function itself. I would say that's the most coarse-grained way of doing it. So I've set up a secondary role here, demo analyst. And if I go ahead and demo analyst here, I run this query here. So we're running as demo analyst, and we've got a decryption function invocation inside of our query. It is not able to decrypt the data. So that's probably the most coarse-grained way that you can govern access to it. You can also, like I said, you can use a masking policy to define specific roles that can get plain text back or masked data back, partially masked data. Almost every masking tool, Alter included, will work with format preserving encryption, because you are preserving the format of that ciphertext, so it'll all look the same if it's masked. There's a lot of functionality that can be realized with something that's very flexible, like format preserving encryption. Let me just take a quick look here over my sheet. Again, we'll just switch back to the account admin role here, just to show that we are able to decrypt the data when we have permission to that function. Let me just take one more look over my sheet here, make sure I'm not forgetting anything. I think the only thing I wanted to mention, we did everything here with the email CS key, and we created this key. You can create as many keys as you want. One of the things about the Alter implementation about FPE specifically is we really want you to have a lot of control over how you encrypt the data. Some of our customers, they like to use one key per data kind of classification. So if it's PCI data, they might use all one key. They wanted to be able, one of our customers, they wanted to be able to have all their PCI data across their entire Snowflake account encrypted with one key so that they could union all of the data together across their many customers and perform analysis over it. Some customers, they're in a multi-tenant system and they've got all of the data stashed into one table, so they like to use a different key per customer, per one of their customers. So in that case, every row could be encrypted with a different key. The Alter system in specific really affords you a lot of functionality and a lot of flexibility with how you manage the keys. Also provide key rotation. So a lot of regulation says you have to rotate your keys every 3 months or 1 year, whatever the regulation is or whatever business outcome you're trying to achieve. You need to be able to rotate those keys. You can do that as well. So I think that that's it for the demo portion. I do have one other thing here. If I just go ahead and switch back to my PowerPoint, I mentioned last time we were talking that I had a special email address. It's FBE1001, FBE1001 at altr.com. So I was able to get one question. This question comes from Jonathan M., who is a data engineer in banking. I did anonymize his role and his company a little bit. He said, I enjoyed part 1 of your series. I'm looking forward to part 2 and 3. I do have one question. Can FPE be used with data other than strings? The answer is absolutely. One of the caveats to that is most of the FPE libraries that you can get off of the shelf, either from the open source community or from vendors, they don't necessarily give you that capability out of the box if you want to do a format preserving encryption on maybe a date per se or a number. You have to do a little bit of engineering around that, and then you have to own that piece of the engineering, maintain it basically and promote it through development lifecycles. Alter happens to give that to you out of the box. But there's a lot of different techniques to do format preserving encryption with other types of data. It's not just strings and varchars. It can be dates, it can be numbers, it can be all sorts of things. So I really enjoyed that question. I think that's a great question for a topic like this. If you have any more questions, I do encourage you to email me at fbe1001 at alter.com, fbe1001 at alter.com. And I really appreciate your time today, and we'll look forward to seeing you on the 3rd and final installment of this little FPE Master Lab. Thank you.